Hello, and today we're going to be looking at the integral of sine to the 4 of x and cos to the 4 of x. Let's start with the sine first of all. So how do we integrate now sine to the 4? This requires an awful lot of trig identities, so let me just start by writing it. And the first step is to actually write the sine to the 4 as sine squared of x all squared dx. Okay, what's our intention? Well, for those who know their identities by heart, I'm going to use the identities. I'm going to write them down here. So the sine squared of x is identically equal to a half minus a half cos of 2x. And symmetrically, the cos squared of x is identically equal to a half plus a half cos of 2x. Let me just show you where the first one is coming from, which I'm going to use it straight away into this sine squared. Let's use a brown pen for this. You start with your cos double angle. Okay, so the cos of 2x, and you're looking for the identity that has sine squared on the right hand side. So that's 1 minus 2 sine squared of x. Make now the sine squared the subject. So let's take that to the left. 2 sine squared of x identically equal to 1 minus the cos of 2x, and then of course just divide both sides of this identity by 2 to give you the desired result, which is of course the very top line that I've just written up there. Okay, so let's do this now straight away with our integral. That is just the inner bracket, so it's going to be a half minus a half cos of 2x by using this identity all squared. I replace the sine squared for this quantity here. Let's not forget the dx. What do we do next? Of course, we must not increase the power by 1 to cube. This, of course, very silly, doesn't work. All we're going to do is square this bracket. So it's going to give us now 1/4. Squaring that, minus, multiply these two quantities and then double your answer. Half times a half is a quarter. Double it is a half. Half of cos of 2x. And of course, we need this quantity squared, so plus 1/4 cos squared of 2x, squared and 2x at the same time. So this is integrable, but now we have a cos squared. The argument is of course 2x. I've written up here already the identity cos squared of x is identically equal to a half plus a half cos 2x. Where do you get this particular identities? Again, from your cos double angle. So if we look at the cos double angle, let me just write it so everybody's happy where these things are coming from. And I'm looking for a right hand side that contains a cos squared. So that's a 2 cos squared x minus 1. Let's make cos squared the subject. So I'm going to add the 1 to the left. That is 1 plus the cos of 2x identically equal to 2 cos squared of x. And then I'm going to write it back to front at the same time, divide by 2. So that's of course the cos squared of x is identically equal to a half plus a half cos of 2x, which is of course this line here. Let's put a little separator there. Okay, but here we have to be careful. We don't have cos squared of x, we have cos squared of 2x. So does the identity change? Well, this identity says the cos squared of x. If we replace now the x here for 2x, and we have to do that everywhere within the identity. So just the x here needs to be replaced by 2x. So this identity now will in fact read, for this particular integral, cos squared, I replace the x for 2x, is identically equal to a half plus a half cos of 2 lots of 2x, so cos of 4x. Okay, so we can actually now replace it in our integral, and this is what happens. Still tidying up, so we got a quarter minus a half cos of 2x. I'm not doing anything with these two terms, I'm just merely replacing them. And then now I'm going to use a bracket, a quarter, and the cos squared of 2x is down here. So that is a half plus a half cos of 4x dx. Okay, after that it's just a big tidy, and we're going to come up with the answer in a few lines. So that's going to be You will allow me to do, or you can use your calculator. This is a constant, so it's a quarter times a half is an eighth. A quarter plus an eighth, we got 1/4. I'm going to write it here. A quarter plus 1/8, so everybody can see is of course 2/4 plus 1/8 is 3/8. You can use your calculator, of course, in a calculator exam. And then we got, of course, minus a half cos of 2x there. And then times in this bracket, we're going to get, of course, 1/8 cos of 4x dx. After that, we can now begin our integration, which is very, very straightforward. This will produce, of course, with respect to x, 3/8 x. Cos of 2x comes from a differentiation of sine of 2x. Sine differentiates to a plus, therefore the minus that I'm seeing there must have been from the beginning. It also produces a times 2, so I need to divide by 2, so half divided by 2 is 1/4. And lastly, to get the cos of 4x, I need to differentiate a sine of 4x. Sine differentiates to the plus, so it's a plus in there, so the plus just gets maintained. And then also a divide by 4 from the differentiation of this 4x. So this is going to give us 1/32 sine of 4x plus a constant. Okay, so that's how you do the sine to the 4 of x. Quite a challenging question, quite a lot of manipulations involving trig. Let's attempt now. I'm going to leave the identities there because we're going to need them again. I'm not going to reprove them. Very, very quickly, we can perhaps look at the integral of cos to the 4 of x. If we know how to do sine to the 4, we should be able to tackle now the the cos to the 4 of x. Let's do that very, very quickly. So cos to the 4 of x dx, same or rather identical steps. We're going to write it as cos squared all squared dx. We're going to replace this cos squared with the identity that we just derived or we know by heart. I do advise you to actually learn this identity, particularly if you're going to do further maths. So this is going to be a half plus a half cos 2x all squared dx. Square the bracket out, so that's going to give us 1/4 plus half times a half is a quarter, doubled is a half cos of 2x plus this quantity squared, which of course is 1/4 cos squared of 2x dx. Integrable, that has a cos squared, so we need to reapply the identity. We've gone through all of this, so we have the cos squared of 2x written in blue down here. So all I'm going to do now is again use it. 1/4 plus a half cos of 2x plus 1/4 bracket. Cos squared of 2x is a half plus a half cos of 4x. Tidy up the numbers. A quarter plus an eighth, we've done it before, it was a 3/8. Okay, and then we got just very simple material, just the final tidy now. That's this bit here, and then we got a quarter times a half, which is 1/8 cos of 4x dx, and finally the integration 3/8 of x. Cos of x needs to start from the differentiation of sine 2x, sine differentiates to plus, all good, times 2, divide by 2, so that's a quarter in front of it, and then we need to differentiate the sine of 4x, sine goes to plus, so it's all good, and again 1/32 sine 4x plus a constant. Very, very similar expression as the one we had before. And this is the end of the little talk on these two quantities. I hope you enjoyed it, and of course this is the end of another video. I hope you learned something. I'm signing out.